I recently did some testing with these two batteries. One of these is a Duracell alkaline battery, and the other one is a nickel metal hydride battery. These are both D cells. I have a candle in the foyer that I use. It runs all the time, and it takes 2D batteries. And so what I decided to do was I put a pair of Duracell batteries in it and counted how long it lasted, and then I put a pair of these nickel metal hydride Sunlabs batteries in it and saw how long it lasted with those. So with the Duracell batteries, I mean, this is within maybe a 10-15 hour margin of error. The Duracell batteries last about 11 days, and the nickel metal hydride batteries lasted about 9 days. So in this particular use case, the Duracell batteries did last notably longer, but there's a lot more to the story than that when you get into battery discharge, because the capacities, it kind of varies a lot with alkaline batteries depending on the use case. Alkaline batteries work very well in situations like the candle. It's a low power draw over an extended period of time, whereas nickel metal hydride batteries, they can provide more power for longer and higher voltages. I made a graph here, and this is kind of barely scratching the surface, but just to give an idea of the scenario, an alkaline battery discharges very steadily. So let's say the X is time and the Y is voltage. As time goes on, the alkaline battery's charge the voltage will discharge pretty evenly, and it starts immediately. And that's one of the reasons why alkaline batteries don't work well in electronics, because the voltage drops very quickly. Now with the nickel metal hydride battery, the voltage drops pretty gradually for a while, and then it drops down fast at the end. That's how lithium-ion batteries function as well, and so that's why they're better for electronics. So if you have a situation like, let's say, a clock or a television set remote or something like that, where it's a very low power draw over an extended period of time, the alkaline cell will probably deliver more lifespan. I believe the theoretical maximum capacity for these alkaline cells in this size is somewhere around 18,000 milliamps, whereas these I think is 12, and these particular batteries are 10, which is typically what I see. Most of them are about 10. So interesting. They worked okay. Of course, it doesn't really matter if it works okay if the battery leaks and demolishes whatever it's in as soon as the charge runs out. That's besides the point. So in the candle, which was a low draw, these last longer, but I think if you were to put these in a different application, let's say a camera or a fan or something that draws more power, you probably would get more life out of these, if nothing else because the voltage would not drop so quickly.